Good evening, respected panelists and the audience. I'm Rukshan Siranayaka from Faculty of Information Technology, University of Mortua, and I'm here to present our paper, SingRAG, a translation-augmented framework for code-mixed Singlish processing. So this is the things that we're going to talk in this talk, and our team has 3 members. And let's start like this. Sinhala is a low-resource language, and let alone Singlish, which is a variant, it's a code-mixed variant of Sinhala with Singlish. In the world, when Sinhala is spoken only in Sri Lanka mostly, the big corporations like OpenAI and Anthropic, their likelihood of creating a separate model to support this niche language is very low. And that is why we came up with this, our research idea, that we are going to develop a framework which can process Singlish effectively. And why? Why do we do this? Sinhala, although spoken largely in Sri Lanka only, this has very important business aspects because people are communicating with their mother tongue, and most of the people in Sri Lanka don't have the English literacy large enough to communicate in English very well. And also when it comes to customer service applications, the availability of such a system will be very beneficial for corporations. And also when you talk about large mainstream language models, their likelihood, as you can see in the diagram, is not even considering Sinhala as a language to support in their initial releases. But considering the youth of Sri Lanka, the main language that they mostly communicate on is Singlish, which is using Romanized version of Sinhala. And the research aim is coming up with a framework that can effectively process the inputs and outputs in Singlish and thereby have various business applications. When talk about the literature that were available in this domain, we came up across several papers, and the first one is Singlish to English translation with transformer neural network, and it only considers Singlish to English translation. But our paper suggests a framework that can do both ways, Singlish to English and English to Singlish as well. And also the neural machine translation for Singlish to English code mixed, it uses LSTM. LSTM loses the ability to process longer sentences when the context is too large. But since we are suggesting a transformer-based approach, that problem is automatically solved. Same for the neural machine translation approach for Singlish to English as well, because it's also using LSTM and also only supports Singlish to English. And we tried with mainstream available models like ChatGPT, OpenAI API, and also Anthropic Cloud. They had some ability to process Singlish, but not in the way that is usable in a commercial manner. And the novelty, which is the most important part in our research, is the ability to process Singlish in both ways. That means a user can input a Singlish input and it will be converted to English. And also, we feed the English output that is coming from the usual traditional RAG as converting it to Singlish output as well. So, this is the methodology. First, we did the upstream task, which is the pre-training of our model to have the language understanding of Singlish, which is a separate language, but we could have used pre-trained models to have the specific language patterns that are already in English, because Singlish is the Romanized version of Sinhala. The reason we used this was Sinhala in itself has very complex scriptures, and the byte data that we need to represent a Sinhala letter is more than what we need to represent an English letter. So that way, we could have easily trained the models using already pre-trained models. And also the Singlish downstream task, which will give us the ability to do things like question answering, translation, which are available to be extended for systems like RAG. The RAG is an English traditional RAG, but we can integrate it with our already developed system. So this is a high-level architecture. So in green color, you can see what we have done, the upstream pre-training, and also the translation fine-tuning and the question answering fine-tuning. And the red color, you can see the traditional English RAG, which is available in the world right now. And also, we give the ability to input the English documents as the traditional RAG, but within our framework, we can input Singlish and also output Singlish as well. So you can see, this is a sample demo. So we have built a chatbot as well. We have deployed it on Azure, but right now it's not available. So you can see, firstly, we take the user's input in Singlish and convert it to English, and then we pass that English converted text to our RAG, which is the traditional English RAG. We then get the output from the traditional English RAG and then feed that into our model and then convert it back to Singlish so that it's presentable to the user. For example, here you can see the source document that we have input into our system is in English. So it's talking about the widget called some like XYZ gadget as an example. So we ask, mehi ena namak mokakda. Like that way we ask in Singlish. And then it goes through the pipeline that I explained earlier, and it's giving us the response in Singlish. Like, it has some nuances and mistakes, but you can see it's giving us the correct name, XYZ gadget way. Like that way it has the language comprehension, how to answer a question. So this is the logs that we have in our running application. And there were a lot of technologies that we adapted. The main was the training infrastructure. We tried a lot of things. We tried Google Colab, we tried RunPod, and finally we used the serverless architecture to run and deploy our models. And also we tried with several tools that would enable us to continually pre-train the already existing mainstream models to what we have. And also we use industry practices like 1DB to keep and save our training records, so everything is accessible. Now the mainstream task or the upstream task we trained using the objective of next word prediction, and for that we tried different approaches, and this is the overall high level architecture. And the first one was we tried with GPT-2, and then there were some problems that we faced with GPT-2. The model was like 124 million parameters, and it was not enough to capture the language patterns of Singlish. We got gibberish most of the time. But then we go into Llama 2, which is like 7 billion model. It was having already nice English understanding, and then we did the fine tuning. So these are some details that I can get into if in the Q&A. And we did the continual pre-training. So these mainstream models already have some knowledge, some language patterns related to English. Since Singlish also use these English letters, there are some things that we can take these rules or the learning, the language patterns to train for our model. And one other thing is, training these large language models is very expensive in terms of computation and time. So we use the low rank adaptation and quantization to make our process much more smoother, so that we can train this using a single GPU. And this is the layers, the model layers that we were fine tuning, because we don't want to harm the original model. We wanted it to infuse the Singlish language patterns and the knowledge without harming the original language patterns in English. And so in the training process, we used several data sets. The first one was we web scraped, we got Sinhala data, and then we turned it into a model, a format that we can feed into our training process using a tool called Axolotl. So it gave us the already standardized training formats and inputs, prompts, like GP Teacher, Instruct GPT. They were very helpful for us to streamline our training process. So I'll skip these things because we want to get into the data sets. And the data preparation was a very interesting thing, because in the literature reviews that we also had, the ability to get data for Sinhala was very limited. And we came up with a transliterator that I'll explain in the next slide. And we tested the upstream task with the Perplexity having a low comparatively with the open source models already available for Singlish, and the blue score was comparatively high as well. And if I go to the downstream task, and we first tested with question answering. We used the extractive question answering and abstractive question answering, and then we used actually the extractive for the GPT-2 and then abstractive for the Llama models. And the in-house transliteration tool is one that we are very proud about, because we have the Sinhala to Singlish romanized version, and then our team developed this to make the data low resource language problem solved. So what we can do is we can input Sinhala data into our model, into our translation tool, and then we can get a separate data set which is with Singlish data. So I can show you this. So you can see we input Sinhala data, and then we get the Singlish data we want. So we can do it. We have implemented Python test, unit test to make our translation tool much more straightforward. And in the fine tuning, we have three approaches. The first one is a naive approach. So we had the Singlish questions and the Singlish answers. It did not yield very good results. And then we came up with the hybrid approach. So we had the Singlish input, English context, and then the Singlish output. It gave some result, which was good, but it was not good enough, and that is why we came up with the Translation-Augmented RAG. So we give the input in Singlish, we convert it to English, we feed it into RAG system, we get the output, and then we convert it back to Singlish. So that is the overall architecture. And then you can see the data set that we trained and the epochs that we have trained. And the compute that we used, also we had to invest some money into the process. So the Q&A evaluation we did with 50 data examples, so we could have done more on that. and the results that we got for the Q&A was comparatively higher than the already existing open source models. And also we tested with Llama 3 8 billion, but we didn't have the time to train a separate model, so we stick to our Llama 2 7 billion model. So this is our web interface that we have deployed, and also we deployed in Azure as a model, and these are some of the costs that we have invested into our training. So the limitations of our system, we know we have used synthetic data to, using seed data to have the pre-training and also the fine-tuning data set. So we could have used some data annotators, independent data annotators to do that. And also the translator has some small bugs like the initials of a singular name are not properly transliterated. So these things are we hope to do in the future work. So we are mostly interested in the data set, and if we have more funding and more time, we could have improved this. But this is a highly scalable system that we can have, and also this is, it's a framework that businesses can use in the real world to have their customer supports or their chatbots in the online world as well. So thanks a lot for watching, listening to my speech, and I'm open to questions. Thank you.
Okay, thank you for interesting presentation, and actually it's an important topic these days because NLP has revolutionized the recent development in this artificial intelligence and NLP area itself. Can I ask a question first? Floor is open for discussion. Okay. Well, actually, I am about 15 to 20 years ago, actually, I was also interested in this area very much, especially English to singular machine translation kind of thing. Then this code mix idea, I have a small concern before going to this large scale translation and so on, which is really yet to be improved a lot. My problem actually when we are using, say, sometimes we are sending SMS and other messages using English letters for typing Singlish terms. So then at least can we really now maintain this commonality between two parties when I can type something in one way, you can type the same thing in a different way. Can that issue be addressed at the moment?
Exactly. So that was one thing that was mentioned in the literature as well. For example, if I take the word mama, some people can type it M-A-M-A, and some people can take it M-M. So it's still, the two people are meaning the same thing. So that is very much, under the patterns that since we are using a transform architecture, that is captured. So during our testing, that was captured. So it's not like using any LSTM or anything. Because this transform architecture and with the more training examples that we show it in the fine-tuning and the upstreams, because the upstream data set has a lot of these variations. So it's also having MA and also MM. So the model is able to capture these patterns. So we found that in our testing, yes.
Thank you.
You're okay.
Yeah, thank you for your interesting presentation. So very interesting area. So I have a few clarifications. So so you mentioned about different applications. So like use translating this English into English and translating back into the Singlish as well. So can the companies like Amazon or any other Daras or something like that, those companies, can they use this for their forecasting purposes or something like that? Do you think that they have the application on that?
Exactly, they have. So we have this idea that most of the documents or the knowledge bases companies have, they have in English source documents. That means without trying to reinvent the wheel, what we did was let your English documents be in English, but you have a way that you can interface with the customers who don't have the English expertise, but still they can communicate in Singlish. That is very much possible, and we have submitted our abstract to, it's a competition, hackathon, for a bank. So their exact use case was, we need a way, without making external API calls to OpenAI, which is very costly, we did to our synthetic API data generation, they don't want to have an API call. They want to have everything on premise. They want to have a big VM with a GPU and beef everything. So this is very possible. We can take a VM, deploy a model. In fact, we have done that. We have done it in RunPod, so we have deployed everything. No external APIs are used. So everything is a model and open source available. Llama 3 is open source available, which are using for the RAG. So companies can definitely use it. What they need is, they need a VM sufficient enough with resources to run these models, and they need the source documents. That's it. If they have the models, they can run it. No external OpenAI or anything is needed. In fact, in our literature review, we found that some companies in Sri Lanka have done it, but they have done using OpenAI calls, API calls.
Okay.
So it's not very scalable. They can't do it because it's very expensive. But this, they can use definitely.
Okay, yeah, yeah, and also maybe they can use the sentiment analysis as well to analyze the opinion of the maybe the messages or maybe the comments on the products as well.
Exactly. We tried that. We tried to have the emojis and what people use in the emojis, but we couldn't complete that. That's why we didn't include it, but we looked into that as well. So sentiment is very much important because some people use emojis in different contexts. So some people use the thumb hand sign in a passive aggressive way, but some people use it to just say their appreciation. Like that way, we have tried it, but not included in this research, but we are hoping to do some future work.
Yeah, yeah. Thank you. Good work.
You're welcome. You're welcome. Thank you.
Okay, thank you. We go for the next presentation. UAV-based building crack detection using convolution neural network.